Okay, I hope I'm audible to all the students who are attending this lecture. Okay, so we continue with joint probability distributions. We continue with joint probability distributions. Okay, and I'm quickly revising with you the definition for joint probability density function, which we had done in the last lecture. So let's look at this definition. Let capital X and capital Y be continuous random variables. Let capital X and capital Y be continuous random variables. A joint probability density function. A joint probability density function f of xy for these two variables is a function satisfying the following. First, f of xy, which is the joint PDF, is greater than equal to 0. And the second property is that area under the joint probability density function, that means double integral from minus infinity to plus infinity, f of xy dx dy is equal to 1. So this is the definition from the previous lecture on joint probability density distributions. Let x and y denote continuous random variables. A joint probability density function f of xy for these two variables will be a function satisfying f of xy greater than equal to 0 and double integral from minus infinity to plus infinity f of xy dx dy is equal to 1. Okay, then we had done a note also. In particular, if the set of x comma y is such that x lies between small a and b and y lies between small c and d, then probability that x lies between a and b and y lies between c and d, where x and y are continuous random variables, is integral a to b, integral c to d, f of xy dx dy. So we had done this note also, and then we had done a practice question for which you can all refer to the previous lecture. Okay, now what we are doing marginal probability density function. So this is our next topic, marginal probability density function. This is a fresh topic for today. Marginal probability density function. So let's look at the definition. The marginal probability density function of x, random variables x and y, denoted by fx of x and fy of y, respectively, is given by fx of x is integral from minus infinity to plus infinity. You integrate the joint PDF with respect to y for x lying between minus infinity and plus infinity. And the marginal probability density function of y is you integrate the joint PDF with respect to x for y lying between minus infinity and plus infinity. So all students, please understand this. The marginal probability density function for x, how will you find it? You will integrate the joint probability density function with respect to y. That will give you the marginal probability density function for x. And if you integrate the joint probability density function with respect to x, you will get the marginal probability density function of y. So it's the reverse. To find the marginal PDF of x, integrate the joint PDF with respect to y. That means you will vary y. Similarly, to find the marginal PDF of y, you will integrate the joint PDF with respect to x. That is, you are letting the x to vary. Okay. Remember, we have covered marginal probability distribution function in the previous lecture. When x and y were discrete random variables, we had found out the marginal probability distribution function or mass function. Marginal probability mass function. Today we are doing the same concept but for continuous random variables. Okay, so now guys, let's do a practice question on this. Let us look at a practice question. So consider the same question which we had done in the last lecture. So the question was as follows. A bank operates both a drive-up facility and a walk-up window. This is the example we had taken in the last lecture. On a randomly selected day, x denotes the proportion of time that the drive-up facility is in use. Proportion of the time the drive-up facility is in use. And y denotes the proportion of the time that the walk-up window is in use. Walk-up window is in use. Okay, and we are given the joint probability density function f of xy is, if all students can recall from the last lecture, it was 6/5 into x plus y square for x lying between 0 and 1 and y lying between 0 and 1 and 0 otherwise. Okay, so now the question asks us the following. So question asks us find the probability distribution. Find the probability distribution of the busy time for the drive up facility without reference to the walk-up window. Second thing they ask us, find the probability distribution of the busy time for the walk-up window without reference to drive-up facility. Without reference to the drive-up facility. And then they ask us, third thing, find the probability that y lies between 1/4 and 3/4. So it's a big question. We are given x denotes the proportion of time that the driver facility is in use. Y denotes the proportion of the time the walk-up window is in use. We are given the joint PDF 6/5 times x plus y square for x and y lying between 0 and 1 and 0 otherwise. The question asks us to find the probability distribution of the busy time for driver facility without the reference to the walk-up window. Okay, then the question asks us to find the probability distribution of the busy time for the walk-up window without reference to the driver facility. The third point, find the probability that y lies between 1/4 and 3/4. So guys, let's solve this question. Okay, so now to solve this question, first of all, let me erase the question itself. You know the question now. I had written the question just to make you familiar that this is the case we had taken in the last lecture of joint probability distribution. However, I'm erasing the question now and we are solving it. Now, what is the first part asking you? Find the probability distribution of the busy time with respect to the driver facility's random variable x without reference to the walk-up window. That means the first part asks you the marginal probability density function of x. So marginal probability density function for x will be integral from -infinity to +infinity f of x y dy, which in our question is going from, y is going from 0 to 1, y is going from 0 to 1, f of xy is 6/5 times x plus y square dy. That means we need to integrate with respect to y. So first of all, 6/5 comes out. Integral 0 to 1 x plus y square dy. Now this is going to further come out as 6/5 times. If I integrate x with respect to y, now x is a constant. If I integrate with respect to y, I get xy plus y square ka integral is y cube by 3. I will run this from 0 to 1. So this will be 6/5 times. I'll put y as 1 first. So x into 1 plus 1 cube by 3, which is 1/3. And then I'll put 0. I'll put y as 0. I get everything 0. So this will be 6/5 times x plus 1/3. So this makes it 6x by 5 plus 2 by 5. So this is my marginal probability density function of the driver facility. So this is my answer for part 1. Probability distribution of the busy time for driver facility without reference to the walk-up window. Now the same thing I can do. The second thing is asking us find the probability distribution of the busy time for the walk-up window without reference to the driver facility. So now what I can do, I can erase both these parts. The second part is asking us to find the marginal probability density function of y. Now all students can quickly start doing it in the registers without wasting time. Please try yourself, although I'm solving it on the whiteboard, but I request students to try themselves. The second part of the question asks us to find f, y, y, which is in general minus infinity to plus infinity. F of xy you integrate with respect to x. Now x in the question goes from 0 to 1. F of xy is 6 by 5 times x plus y square. You integrate with respect to x. 6 by 5 comes out of the integral. It's a constant. When I integrate with respect to x, x ka integral is x square by 2 plus y square. Now y square is a constant. When you are integrating with respect to x, y square is a constant, and the integral of that will be xy square. And I will run this from 0 to 1. So then what will it come out? Now it's easy. This is 6 by 5 times, put x as 1, so 1 by 2 plus y square, minus put x as 0, you get everything 0. So my answer comes out as 6 by 5 times half plus y square. So this will be 6, this will be 3 by 5 plus 6 by 5 y square. So this will be my answer for the second part. So guys, I can write the answers like this. Okay, how will I write the answer formally? I am doing it on the top. So formally fxx will come out to be, it will come out to be 6x by 5 plus 2 by 5 when x lies between 0 and 1. When x lies between 0 and 1 and 0 otherwise. This is how you formally write it. Similarly, my fyy will come out as 6 by 5 y square plus 3 by 5 for y lying between 0 and 1 and 0 otherwise. Now the third part they ask us, find the probability that y lies between 1 by 4 and 3 by 4. How will you find this? You will integrate the marginal probability density function of y from 1 by 4 to 3 by 4. Since there is no x involved, they are asking you find the probability that y lies between 1 by 4 and 3 by 4. That means the marginal PDF of y you will integrate from 1 by 4 to 3 by 4. So this will be integral from 1 by 4 to 3 by 4. What's the marginal PDF? This is the marginal PDF. 6y square by 5 plus 3 by 5 times dy. So this will be 6 by 5 times y cube by 3 plus 3y by 5 and you will run this from 1/4 to 3/4. Now this is something you can try at home, and you can check that the answer will come out to be 37/80, which is 0.4625. You can try this at home now. Put 3/4 in this expression and subtract, then put 1/4 in this expression. So you will get 37/80, which is 0.4625. So this is our answer for the entire question. First part was asking you the marginal PDF of X. Second part was asking you the marginal PDF of Y. Third part was asking you to specifically integrate the marginal PDF of Y from 1/4 to 3/4. So I hope all students are clear with this. Let's do another practice question. So I'm erasing this off. So another practice question, very important. A nut company market scans of deluxe mixed nuts containing almonds, cashews, and peanuts. Let X denote the weight of almonds. Let X denote the weight of almonds in a selected can, and Y denote the weight of cashews. Suppose the region of positive density is given by, so the region of positive density is given by set of X comma Y such that X lies between 0 and 1, Y lies between 0 and 1, and X plus Y should be less than equal to 1. And the joint PDF is given by f of xy is 24xy for x lying between 0 and 1, y lying between 0 and 1, x plus y less than equal to 1, and 0 otherwise. So the question asks us to answer the following. First part, is f of xy a legitimate PDF? Is f of xy a legitimate PDF? Second part, they ask us, find the probability that the two types of nuts make up at most 50% of the can. And the third part which they ask, find the marginal PDF of almonds. Find the marginal PDF of almonds. Okay, so we have all read the question. X denotes the weight of almonds in a selected can. Y denotes the weight of cashews. And a can consist of three types of nuts: almonds, cashews, and peanuts. Obviously, the leftover part after filling in almonds and cashews will be peanuts, the leftover part. So we are given the region of positive density that x and y lie between 0 and 1, and x plus y is less than equal to 1. So if we plot the density, if I plot it, how will it look like? X, y, when x is 0, y is, if I plot this inequality, how will I plot this inequality? If x is 0, if y is 0, x is 1. If x is 0, y is 1. It will be a line passing through this. And x plus y less than equal to 1 means my shading will be in this direction. So this is my region of positive density. This is my region of positive density. Okay. So and there is one more condition: x lies between 0 and 1, y lies between 0 and 1, x and plus y should be less than equal to 1. That means if I take a point on this, on the boundary, if I take a point, if this point denotes x here, then this will denote 1 minus x here. Because if x plus y is equal to 1, on the boundary, x plus y equal to 1 implies y is nothing but 1 minus x. So this point corresponds to x comma 1 minus x. So now let's solve all the parts one by one. I hope all students have written down the question. We are given f of xy. We are given the positive density. We have plotted it in the graph. Now we answer the questions. Is f of xy a legitimate PDF or not? So first of all, you can see that f of xy is equal to 24xy, which is greater than equal to 0 for x lying between 0 and 1, y lying between 0 and 1, and x plus y less than equal to 1. So the first criteria is met. For a function to be a legitimate PDF, it should be greater than equal to 0. Now 24xy will always be greater than equal to 0 when x and y lie between 0 and 1, and their sum is less than equal to 1. What's the second thing we need to show within part 1? The second thing we need to show is integral from 0 to 1. Now x goes from 0 to 1, y also goes from 0 to not 1. Y will go from 0 to 1 minus x. If I would have not put this inequality, then you would have said that y goes from 0 to 1. But this inequality is also there. So if I am allowing x to move from 0 to 1, then y can move only from 0 to 1 minus x. You cannot let y vary from 0 to 1. You could have done that if I would have not given you this inequality. But since I have given you this inequality, since this inequality pretty much exists, if x goes from 0 to 1, y also goes from 0 to 1 minus x. F of xy dx dy. Let's calculate how it's coming out to be. Integral x goes from 0 to 1, y goes from 0 to 1 minus x. F of xy is 24xy dx dy. Let's integrate this with respect to y first. So let's bring 24 out. Let us bring 24 out. So this becomes 0 to 1, 0 to 1 minus x, xy dx dy. Now let us integrate this with respect to y first. So integral 0 to 1. If I integrate this with respect to y, I get xy square by 2. And I will run this from 0 to 1 minus x. So this will be 24 into, as x goes from 0 to 1. If I put y as 1 minus x into 1 minus x ka square by 2. And if I put y as 0, everything becomes 0. So this is what I have to integrate now. So guys, I can bring 2 outside, and 24 divided by 2 will be 12 times integral 0 to 1 x into a minus b square a square plus b square minus 2ab times dx. So this will come out as 12 times integral 0 to 1 x plus x cube minus 2x square times dx. Now we know the question, so I am erasing this. I am erasing the question now. Okay, so let's further integrate. So we are continuing with part 1b. So 12 times, if I integrate it, x ka integral is x square by 2, x cube ka integral is x4 by 4, minus 2x square ka integral is 2x cube by 3. And I will run this from 0 to 1. So this will be 12 times 1 by 2 plus 1 by 4 minus 2 by 3. Guys, if I put 0, everything will become 0. LCM 12, 2 6s are, 4 3s are, 3 4s are, 4 2s are 8. So this will be 12 into 1 upon 12, which is exactly coming out as 1. So I can say that therefore integral 0 to 1, integral 0 to 1 minus x, f of xy dx dy is equal to 1. Therefore f of xy is a legitimate PDF. Therefore f of xy is a legitimate PDF. Because to qualify as a legitimate PDF, it has met both the properties. It is greater than equal to 0, and at the same time, the area under the joint PDF is exactly equal to 1. Now, the second part, they ask us, what is the probability that the two type of nuts make up almost 50% of the can? So what is this part asking us? So if I now erase the initial part, if I now erase the initial part, so this part is asking the following, part 2. What is the probability that the two type of nuts make up at most 50%? 50% means probability of x plus y less than equal to 0.5. That means if I let x go from 0 to 0.5, then y can go from 0 to 0.5 minus x. If x goes from 0 to 0.5, so in this diagram, this is 1 1. I can put it like this. I can quickly plot another diagram you can see on the graph. This is x, this is y, This is passing through 1, 0 and 0, 1, and this is passing through 0.5, 0 and 0, 0.5. Now we need to find this area in part B. So if I take a point on this line, what will this point denote? If I take the value of x, if I take a particular value of x here, then y will be 0.5 minus x. So as x goes from 0 to 0.5, y goes from 0 to 0.5 minus x, 24xy dx dy. Now guys, we have already integrated it. So this I can quickly write 24 times integral 0 to 0.5, integral 0 to 0.5 minus x, xy dx dy. We have already done the integration. Integral 0 to 0.5. This will be, if I integrate with respect to y, xy square by 2, I will run this from 0.5 to 0.5 minus x. This will be 24 times integral 0 to 0.5 into x by 2 into 0.5 minus x ka square times dx. 2 comes out, 24 divided by 2 is 12 times integral 0 to 0.5, 0 to 0.5 x times 0.5 minus x ka square will be 0.25 plus x square minus x times dx, a minus b whole square. This makes it 12 times integral 0 to 0.5, 0.25x plus x cube minus x square times dx. If I further integrate it, this will be 12 times 0.25 x square by 2 plus x 4 by 4 minus x cube by 3, and I will run this from 0 to 0.5. Now guys, this part you can try at home. Put 0.5 in this expression. You will get the answer as how much? You will get the answer exactly as 0.0625. 0.0625. Okay. And how do we find the marginal PDF of almonds? This is something which I will be doing in the next lecture. So what we have done in today's lecture, we have done the definition of marginal probability density function, joint marginal probability density function. And in this lecture, we have taken up the question of almonds and nuts, and we have solved out part 1 and part 2. Part 3, which is marginal PDF of almonds, I will be solving in the next lecture. When will the next lecture start? In a few minutes, I will be putting on the group. When I put on the group, then everyone will join using the same link. So be active on the WhatsApp group. Okay. This is where I stop.